Well, that was a great introduction. Thank you. I'd like to introduce Dorsey Pearson, who is our next presenter. He grew up in rural northern Idaho, and he came to Willamette to study environmental science and chemistry with a focus on environmental toxicology and remediation. He has spent the past 2 years conducting research at the Ness of Brodgar archaeological site in Orkney, Scotland, analyzing geothermal trends using X-ray fluorescent spectroscopy. I said the word. He is very excited to graduate from Willamette this coming May and is looking forward to his upcoming internship at the Hanford site, along with pursuing a master's degree in environmental science at Trinity College, Dublin in Ireland.
All right, can everyone hear me okay? A little bit more? All right, can everyone hear me now? Yes. Sweet, wonderful. All right, so I'm very excited to be here this afternoon because this is kind of this is putting a bow on the research I've been conducting for the last 2 years. This has kind of consumed my life a little bit in a very wonderful way. Without any other prelogue, I want to just present my research I've been conducting over the statistical and spatial visualization of the floor geochemistry and structure rate at the Ness of Brodgar archaeological site in Orkney, Scotland. So a quick introduction to Orkney. Orkney is an archipelago off the very north coast of Scotland. As you can see in that map there, it's the island chain in orange. It's a very different portion of Scotland compared to the mainland. It has had a very distinct history compared to the rest of Scotland. While Scotland has had a long history of Celtic peoples, the majority of people in Orkney are descendant from the Norse. This used to be an area that was considered a southern outpost of the North Viking Sea Empire, and as such, it's got a distinct cultural feel and history. They say in Orkney that if you scratch the surface of the land, it bleeds archaeology. And from my research there, I think that's absolutely true. Because of the many peoples that have lived here over the millennia and the very specific geological and weather conditions, not only are there a lot of archaeological sites, but they're very well preserved. There's a lot of archaeological sites from many different peoples over the millennia, from the Neolithic period, which I'll be discussing about, to the Pictish, to Celtic, to Norse, and even modern sites, mostly stemming from World War II. The area was actually the base for the British Navy during the First and Second World War. The area itself is spectacular. It's beautiful. It was one of the most unique experiences I've ever had in my life. And before I delve into the research, I want to talk more about the area in general. So this is a picture of where I was staying for my time in Orkney in the summer of 2024. This is the city of Stromness. It's a very quaint, beautiful little town. It's got a very vibrant culture. I really enjoyed my time here. It's very funny though, because a lot of the local Orcadians refer to this town as Strumhole. And I don't think you can really like a place until you act like you hate it. So as you can see, actually one of the buildings in that photo is where I was staying while in Orkney. This is some pictures of the Orcadian landscape. The mountains in the middle photo are called the Hills of Hoy. So in Orkney, the largest island is called the Mainland, which is a very unique way of naming things. So Mainland Orkney is where the majority of the population lives, with Kirkwall, and Stromness. However, on the southernmost island is Hoy, which contains those very large mountains. I had the opportunity to hike those mountains. This was after a week where I was very, very ill because of all the, it was very cold and we were working outside a lot. I was quite ill and I got to wake up very early in the morning and go on a ferry and go to the island of Hoy. When I got there, I was hiking in steel-toe work boots that were very hard to walk in. And I was with these two gentlemen. One of them was from Germany, the other one was from France, and they were very in shape at the time. And we got to the hills of Hoy, and I guess you can see just from the distant photo there, they're very steep. The southern one that we decided to hike and climb, there's about a 1,000 foot elevation gain within 300 feet. So it's just like that. This killed me. This was very tough to hike, but when we got up there, the scene was beautiful. You can actually see mainland Scotland from the tops of the hills of Hoy. The rock formation on the left is called the Old Man of Hoy. Whenever you come in to Orkney via ferry by way of Stromness, you will be greeted first by the Old Man of Hoy. It's a very large ski stack. In fact, I don't think that the scale of this geological formation is really captured in my photo. If we were to zoom in, you would be able to see people climbing that. And they're only little pixels in that photo. And of course, there's sheep everywhere. This is a very agriculturally productive area. I was told some of the best mutton and cattle in the United Kingdom, which I ate a lot of, but didn't seem to be any vegetables in the entire island chain, which was quite funny. But here's just another picture of the Orcadian landscape from the island of Hoy. And this is a very unique place, not only in its history, but also in its ecology. And I very much love to see the natural environment of this area. So let's delve into the research now. I worked in the summer of 2024 at the Ness of Brodgar archaeological site. The Ness of Brodgar is an archaeological site dating back between 3,500 and 2,400 BCE. Not only is this very old, being about 5,000 years old, this was also in use for a very long time. There's not many structures I can think of at the top of my head that are still being used today that were built 1,000 years ago. The site itself is a part of the Heart of Neolithic Orkney UNESCO World Heritage Site, along with the Standing Stones of Stennis, Ring of Brodgar, the Barnhouse Village, and the Maeshowe Chambered Cairn. And I'll get to all of those in a quick second. The Ness itself is considered one of the premier archaeological sites in Northern Europe, and it's very large. The site itself comprises of multiple different very large trenches, and within those trenches are the excavations of these ancient Neolithic buildings. These buildings are, again, very large. A lot of them are larger than modern-day dwellings. They were constructed using stone, a lot of times on a dry stack formation, which is surprisingly very weather resistant and also very much well preserved, again, due to the specific conditions in the area. The history of site is very interesting because this was not a place of continuous habitation. That is, we are very much certain about that. This was a place, rather, where people from all over the Orkney Isles were coming together to congregate. The question is somewhat up to debate on whether or not this was for political reasons, or religious reasons, or cultural reasons, or economical reasons, but the fact of the matter is this was a place where people were coming together and performing actions such as ritualistic animal sacrifice, feasting, and congregation. So here's a quick map of the Heart of Neolithic Orkney UNESCO World Heritage Site. The Ness of Brodgar lies within a thin isthmus between two lochs, On the north side is the Ring of Brodgar, which is a very large stone circle similar to Stonehenge. And on the south side is the Stones of Stennis, which is also a standing circle, but it's smaller in scale. Close to that is the Barnhouse structure, which is believed to be a part of a Neolithic village, so a place that was of continuous habitation. And the Maze Howe Chambered Cairn, that one is interesting to me. That's the only one I didn't get to go to. That's tough to get into. So these are the standing stones of Stennis on the south side, and they're smaller in structure, and there's a lot of them that are, standing upright. And looking at them, they seem a bit different. The way that I had it explained to me by my tour guide is it's very much likely that this was not the orientation that they were in during the ancient Neolithic period. Whether that be from human interference or natural occurrence, it is different. I was also told of a story that occurred in the 1800s regarding dynamite, and I unfortunately heard a lot of stories regarding dynamite at different sites, and I may answer some questions on that at the end if we have some time, but there was some explosions involved. And then this is the Ring of Brodgar. This is another large standing circle. In my photos, I don't feel like the scale of the ring is also given justice, but this is very wide area with a lot of standing stone structures as well. And then this is the Maze Howe Chambered Cairn. This one intrigues me quite a lot personally. There's not a lot known about this structure. It was raided long before modern archaeologists came to inspect a lot of the artifacts. So there's not a ton of artifacts within the structure. However, it is somewhat easy to presume that this was a significant structure for this Neolithic group. That's because a good portion of the entrances at a lot of the archaeological sites, the buildings with these entrances, would face Maze Howe. So when you would exit the building back 5,000 years ago, you would be within eye shot facing this chambered cairn. It's also designed in a way where it's very dark inside. Except on the winter solstice, the way that the entrance was constructed and designed, it allows sunlight in and illuminates the entire area, which is shown in that photo there, which is really fascinating and I find somewhat creepy, but it just goes to show we know so much and yet so little. So here's a quick map for the Ness of Brodgar. Again, this was a place of some sort of congregational significance. The site itself used to lay in farmland. In fact, the Ness of Brodgar, translated literally, means the headway between the farm bridge, which essentially means the farmland in between the water. The story I was told is that a very large piece of stone was hit with a plow, and that's when excavation began. When I worked on site, there was a multitude of these very large trenches that were in excavation. There's been a lot of trenches that have been excavated over the years, but the three big ones when I worked were Trench J, Trench P, and the newest out of the three, which was Trench T. When I did physical excavation, I did a lot of excavation in Trench T and some in Trench P, and then I analyzed sediment samples between all three trenches. So here's a quick schematic of the structures found in Trench P, which was the largest trench. So as you can see here, these structures, the gray there is the outline of the stone walls that made up the structures. These structures are very large, again, and they're put together in kind of a haphazard way. And with a site used for this long, you're going to start making renovations. The one structure I want to point out is Structure 8. So Structure 8 is one of the larger structures on site. It's also the structure with the most amount of research done to it. over the summer, I focused particularly on structure 8 to analyze the geochemical measurements that we have made. And we decided on this one again because it's large and it's very well documented. As you can see at the top left-hand corner of structure 8, there's a section that has been bitten out by structure 10, likely where they knocked down the wall to make an expansion later on for that large structure as well. Here's an aerial view of that same area. On the left is the aerial view of Trench P. And then on the other side is an aerial view at an angle where you can see Trench P, the laboratory and car park, and then Trench T. There's likely a lot within this entire isthmus that has not been excavated. There's only so much time available to excavate this material, but it's very much likely that we were parking and walking and doing all sorts of things on very fascinating archaeology. Here's another quick photo of Trench T on the left and Trench P on the right. Man, that's such a tough workplace to have to be in. It was really beautiful a lot of the time whenever it was sunny, but it would get very rainy and it would be very, very difficult to perform a lot of work. A lot of these images were from the last day of excavation in 2024. So the site ran between the years of 2003 and 2024. It closed down to better preserve the archaeology for future generations and allow the structures to be returned to the natural way that preserved it for so long. Now, when I was doing excavation on Trench T, I did find some pretty cool stuff. A lot of cattle bone, which was very much present due to the ritualistic animal slaughter. There was a lot of dead animals in these trenches. But this was my favorite find, which was a large, about 3-inch flint knife. So I got to discover that and catalog that, and that's somewhere in the archives, either in Orkney or elsewhere in Scotland. That's a fun feeling. This is, again, photos from the last day of excavation. It was a very somber feeling to be there, but it was also a good feeling. It was a very interesting kind of feeling just to be there. It was very happy, bittersweet, I would say. So we're going to get now to my research that I conducted. So this is an X-ray fluorescence spectrometer. The way that this works is you put a sediment sample on the top here. I would have a stand with it so I wouldn't be waving it around. And the way that it works is you put a sediment sample in a cup on top and you pull the trigger and you scan it. What this does is it penetrates the individual atoms within the sediment sample and it causes them to excite. Around the atoms are small particles known as electrons. Within the innermost electron orbital, the X-rays produced by the XRF excite that innermost electron and cause it to eject. That ejection forces an electron from an outer shell to step down to fill that vacancy. That action of going from a high to low electron orbital creates a secondary fluoresced X-ray. That secondary fluorescent X-ray is then read by this. It's read as spectra. Put this down. So each one of those spectra acts as a fingerprint to which we can identify what elements are present and in what relative concentration. So by doing this, we can start making interpretations on what was going on site 5,000 years ago based on what's there and how much of it is there. So the way that we did this, we would produce a grid along the floor samples of site. And we would take sediment samples in 50 centimeter by 50 centimeter intervals. The samples would then be bagged, written in a little plastic baggie, sent to the lab, and we put them in small Chemplex cups to dry for 24 hours because excess moisture would hinder some of the applications. The samples would then be scanned between two filters, both known as the none and yellow filter. The none filter was used to look for elements in relatively higher abundance, such as your irons, your coppers, things of that sort. And the yellow filter was used to scan for rare earth elements and low Z elements. These elements would often be washed out a little bit within the none filter, so it would be best to use that filter to find these elements. Each sample would then be scanned between both of these filters twice, so twice between the none and twice between the yellow. Each scan would take a total of 30 seconds, which would mean 2 minutes of scanning plus an extra 30 seconds of switching samples over and writing things in the book. So each sample would take about 2.5 minutes to scan. That doesn't sound like an issue until you take into the fact that we were scanning thousands of samples. I think my record, I got up to 3,500 by the time I was done scanning, and I'm sure Professor Pike has done much more than that over the years. So it's very time intensive. It's not difficult, but it is time intensive. And you need to be very organized when you log the information in both the physical book and the computer, because then you'll have a headache down the road, which I'll gladly talk about. So after excavation ceased in 2024, we wanted to start organizing and analyzing these geochemical data. So many people have worked on this over the years, with this project scanning the better portion of 2 decades. Many people have excavated, many people have scanned, many people have worked on this site. And I was able to put the beginnings of a small bow on all of this. I was very fortunate to work at the tail end of scanning and then work on the data analysis portion. We wanted to do this by creating a geospatial heat map in order to visually analyze the geochemical trends in a way that is understandable and easily identifiable. We also want to create a process that we could replicate on multiple structures on site, but also be able to use on different archaeological sites in the future and possibly non-archaeological methodologies. To do this, we created a small team of researchers, including myself, Professor Heather Katata-Smalley, who is a data scientist and statistician by trade and a professor of data science here at Willamette. Professor Scott Pike, who's had by far the most amount of research experience in this research and is a professor here of environmental science and archaeology. Haley Bond, who is a current Willamette computer science and data science student, and Avery Pike, who has also had a great deal of research experience on this and is a Willamette Masters in Data Science alum. So we had quite a bit of challenges last summer when we were doing the data analysis. The first one being with scale. We had thousands of samples that we had to analyze, and we had to cut back in some way. We did this by deciding to create a foundation for the analytical technique using structure rate. As I mentioned before, it's one of the larger structures, it's the most research of the structures, and there's a lot of information about it. So we decided to go with that and cut thousands right off the bat. The second issue we had was with naming conventions and organization. As you can take a look at the top of the slide, that is the naming convention we used for all of these samples during our data analysis. And you might look at that and be like, that is a lot of information and a lot of places where something could go wrong, and you'd be correct. A lot of the time that we did over the summer was making everything uniform and correct, because over the years and in different areas on site, there have been different ways of naming things. We had to make sure everything fit the connotations within that specific set of data. On top of that, we also had to factor in human error, which is a very hard thing to factor in a lot of times. Some of this information would be labeled incorrectly, and it would be somewhat difficult to attempt to fix this when the poor labeling occurred, not the poor labeling, the mistake occurred in a mud pit in the rain, writing this information on a Sharpie on a site that's across an ocean that no longer exists and has all happened 10 years ago. So that can be quite difficult. But because of the good record keeping that occurred on site, we were able to remediate a lot of issues. We also had an issue with a lack of geospatial data, which we thought was going to be a much larger issue than it was. So that was quite good to not have that issue. So the way that we conducted data analysis is we used the coding language R. R is a coding language often used for statistical analysis. It's similar to coding languages such as Python, but not as computer science heavy. Because we only did structure 8, we did a total of 1,381 samples. Times that by 4 because you scan it 4 times, and that's quite a lot of information. We would then take all of the samples, make everything uniform, and look at the geochemical values that we got. For each of the sample, we would then normalize all of the other geochemical values to the rhodium elastic backscatter. This is because the rhodium elastic backscatter is proportional to the incidence beam produced by the XRF. What this essentially means is if we make the value for rhodium that we get 1, and then normalize all the other values for the other elements to that, we can use rhodium as a standard to compare the concentrations of all the other chemicals. The spatial variation was then done through RShiny, which is a portion of the R coding languages that allows you to produce websites and applications and things of the sort. And then the data was fasted by phase of excavation. That is the very exciting portion of this I'll be gladly getting to in a second. So the results that we did is after doing the data analysis portion, and using the RShiny application, we were able to produce this small website that housed the data visualization tool. And this is what the website looks like. It's very simplistic. We've updated a little bit since this GIF was taken. It provides the information necessary to understand the research, but most importantly, it houses this. This is the data visualization tool for the geochemical data in structure 8. So what this allows you to do is it allows you to flip through the different elements that we scan for, such as your irons, your coppers, and things of the sort. It allows you to toggle between the 2 different filters if an element is scanned between 2 filters, and then allows you to look at the different faceting phases of the site. What this means is that we have these different layers of excavation that we can compare the different geochemical trends between. So this allows us not only to compare and make conclusions on an XY axis, but also a Z. So we can make conclusions on what was occurring on site, not only when the site was being used, but at different times that the site was being used. So we can see possibly changes in the usage of site as it was in usage over the last 5,000 years. So some quick examples I want to show are some of the elements of interest that I thought were most interesting. I want to open up with the element of bromine. So bromine acts as a proxy for seawater accumulation. So what this means is that if a great portion of seawater comes into contact with an area, there's going to be a high bromine concentration. And you might be thinking, I don't see a lot of dark purple. Isn't this an island with a people in the middle of an island in between 2 large bodies of water? And you're correct. So what this means is not only is the building material very robust, there wasn't a lot of seawater getting into it, but at least in this specific structure, they weren't storing things regarding fishing or boats or going out into the open ocean. Now, one thing we do know about these people is even though they're an island people, they were not a seafaring people. They did not go out in the ocean. Fish was not a very heavy part of their diet. And as someone who's been there, that makes perfect sense because I went in on a very large ship, a very large ferry, and I threw up. It is really wicked waters out there. So they weren't getting on the boats, and I understand. But one thing I do want to point out is on the bottom right, there is a section towards the wall that has a higher bromine concentration. If we compare this to other research, we may come to the conclusion that's where a doorway would be, because when you open up the door, the seawater is going to come in. Another example of this is calcium. Now, calcium, of course, is in bones, and there was very, very large deposits of bone material on site. We dug up so many bones, it became boring. We got bored of digging up these bones because it's all we found. So we could use this as a proxy to understand where not only where bone material is, but also other biological material, either from food or clothes or hemp rope or things of that sort. We can do the same for phosphorus. Phosphorus, of course, is one of the 5 chemicals necessary for life to exist, and it's usually considered the rate-limiting chemical. So we can use phosphorus as a proxy to look at the different concentrations of biological material within the site. And this one is my favorite by far. So copper, of course, is very common in a lot of geological areas. However, the reason that this is interesting is because there's evidence to suggest that the Ness of Brodgar has evidence that this site was the earliest that we know of to use paint and pigments within Northern Europe. And this is very interesting because this is a very old site. Paint was not commonly used at this time. For reference, the site began being produced around the time agriculture was being thought of in Northern Europe. So there's a lot of evidence that maybe there was paint in the area. And we believe that the paint and pigment for a red paint in the area was very heavy in copper. And if we look at the different concentrations of copper, we may come to the conclusion that there's areas within the structure that were painted red. As you can see, there's higher concentrations towards the wall and lesser concentrations towards the middle. Now, of course, everything I said about the last 4 elements needs to be verified and further examined through other research and other modes of explanation. What I say may be completely wrong if we compare it to something else. However, I think it's still a very useful tool to be able to look and see at the different trends and begin to make inferences on what has occurred. So some quick conclusions I want to make about my research. For me, this has been one of the greatest opportunities I've had so far. Not only was I able to go to Scotland and learn about a new culture, a new way of living, and be in a very, very interesting place, it also allowed me to hone in my technical abilities in many different fields. This research allowed me to use an environmental science technique to analyze an archaeological site and then use statistics and data science to examine it. I think that this way of interdisciplinary research is very important, and that rigidity and separation of research is not very good by any means. I'm also very happy to be possibly, most likely, passing the torch to someone in the future now that we have produced this bedwork for this good foundation for this geochemical analysis tool, where we can start looking at all the other structures on site and potentially begin transferring a lot of this data into ArcGIS Pro, which is the industry standard software. I'm very excited about this research, and I'm very glad we're starting to make data analytical inroads and conclusions, and it makes me very happy to be a part of this all. So I want to thank you all for having me here, and I'll be more happy to answer any questions you may have.
Hi, I'm Franca, and I've been to Orkney based on Scott Pike's recommendation and what I learned through archaeology here on campus. You know, what an amazing place it was, and it truly was. So an anecdotal thing is I met Jim Brown at the Circle of Brodgar, and one of the things he told me is, I asked him, how many centuries, how long do you think it'd take to excavate the Ness of Brodgar? And he said, how many centuries do you think it will take us? And I know that the local schools are training their children from kindergarten. So can you speak to this long view of the work that is taking place there?
Yeah, absolutely. So there's a very significant cultural connection to this site. These are these people's ancestors. And they live right next to what their ancestors were doing 5,000 years. And as you said before, they train them, educate and train the young in this area through the primary and secondary school system to know about all of this and be able to conduct research about it. The local university, the University of Highlands and Islands, Kirkwall, does produce a lot of work into this, and they've trained a very large cohort of archaeologists. There's also a lot of thought about the future, as this research is obviously not finished. This will be going on for quite some time. And there's recently been some research that has been conducted that I can't speak yet because it hasn't been published, but they're still working on it. They're producing ground-penetrating radar data, and I think we should all be looking out for what's going to be announced on that because it's very fascinating.
I'm David, and I have just a couple quick questions. Mm-hmm. Was building 8 still being used when building 10 encroached on it?
Yes.
Okay, and then the next one was, what was the sea level at that time when they were being occupied?
I was told this. It was different. It was higher.
It was higher,
It
okay.
was higher. I don't remember the reason why, specifically with Skara Brae, which used to be on the coast, and then went out, and it's coming back again, which is damaging some of the archaeology.
Huh.
So.
Okay, and then, so even at the time of occupation, the sea level was higher?
Yes.
Okay, yeah. And then, is there a way to tell if actual animal sacrifices were taking place in Building 8 as opposed to just consumption?
That's a very good question, actually. When you're doing work with archaeology, you of course have to make conclusions with what you have present. You're going to have to look and analyze the different factors of what you find. We found a lot, of course, of animal bone in very large piles, but that doesn't necessarily mean animal sacrifice, right? It just means a high consumption of animals. And if you find flint knives, that of course, that killed the animal, but you can't necessarily make the conclusion for animal sacrifice. I believe there was some research conducted that made people come to that conclusion, but of course, unless we're there 5,000 years ago, we don't know if it's just high consumption or animal sacrifice. What we do know about these people is that they overconsume to a very high degree. They deforested the land, they killed a lot of animals, they consumed a whole lot, and one of the main theories for why these people died out is they simply overconsumed everything. So no, that's always going to be in question of whether how extreme of a conclusion that is, or maybe they're just eating a lot of them. But I personally am in camp animal sacrifice because I dug up way too much bones to be something else.
Okay.
If they were just eating that much, that's scary. That's scarier.
And then finally, you said that the site, I got the impression, was closed and so that future generations can look at it. What did you do? Did you bury it again? Or?
Yeah, we just took the dirt that we dug up and threw it on top and patted it in a way where the moisture wouldn't seep too horribly in. And yeah, we just returned it to the best of our ability, what we dug it up, yeah.
Fascinating talk. You said the area was not continuously inhabited. Were they there for parts of each year, or would there be extended periods when the people were not there?
That's also very difficult to say. Of course, we don't know a lot about these people. There was no written documents. We only really know about their waste and about what they've made. So I personally do not know what the general archaeological consensus is, but that's going to be something that's very difficult to come to conclusion about, whether or not they're there for like brief periods of time, a big party, animal sacrifice, or there for long expended periods of time, more similar to like a political summit or something of that sort. So that's difficult to say with what we have.
Are there any other questions?
Hi, I'm Virginia. I was one of the committee members that read your research, and I thought, oh, I'd like to go there. But the question is, when do you go there? What is the season? What is the weather like the rest of the year? And how did you deal with all of that weather kind of thing?
Yeah, so there's one season to go, and it is late summer. If you go there any other time of the year, you are going to be miserable. Even when I was there, one day during the big European heat wave that hit Northern Europe, it was early August, and a lot of the Americans were out working with no issue because it was about 75 degrees Fahrenheit. And it was really funny because all of the Orcadians, the Orcadian management demanded that we all take more breaks and drink more water, and we had a very easy day on site. It's just because the temperatures in Orkney are very, very low, and it's very rainy. We were dealing with a lot of rain. And in the winter, you get snowstorms, because what happens is you have very large winter storms come off from northern Russia and hit the North Atlantic and really do some damage on the island. So if you go in July or August and pack a raincoat.
All right, thank you very much, Dorsey. And here's it. What?
I had another question, but she basically asked the same question. It was overcast most of the time you were there?
Yes, sun was very rare.
Okay, thank you.
Here's a certificate and a check. Thank you very much. Appreciate it. And now we've learned all about that. So great. Thank you.